The ground beneath us feels solid, unyielding, and permanent, an ancient foundation that seems to have always been there. But that's just an illusion. What appears motionless is actually in constant slow motion, shifting over timescales far beyond a human lifetime. The Earth's crust is actually a patchwork of tectonic plates, immense slabs of rock that float and drift atop a restless sea of molten rock called the mantle. These plates move because of heat rising from the planet's core, creating powerful convection currents in the mantle that act like invisible conveyor belts, driving the plates above. Where plates collide, dramatic events unfold. Mountains rise skyward, valleys are carved deep into the crust, and vast oceans slowly open or close over millions of years. When a denser oceanic plate dives beneath a continental plate, it's called subduction, a slow, powerful recycling of the Earth's crust that fuels volcanic activity and shapes continents. Subduction zones are hotspots for geological drama, birthing volcanic mountain ranges like the Andes and fueling eruptions that can reshape entire landscapes. Immense friction and pressure build up as plates grind together, storing energy for centuries, sometimes even millennia, deep within the Earth's crust. When this energy finally releases, it triggers the world's most powerful earthquakes, megathrust quakes that can move continents and at times, unleash devastating tsunamis across oceans. Subduction zones are the architects of continents and engines of our planet's most formidable forces, sculpting the face of the Earth over eons. They remind us that Earth is not static, but in perpetual creation and destruction, a world where new land is born as old land is consumed. Understanding these zones is key to grasping the forces that shape our world and to preparing for the natural hazards they bring. Our planet is always in motion, and so are we, living atop a dynamic world that is constantly evolving beneath our feet. The story of tectonic plates is the story of Earth's restless heart, beating with the energy of creation and change. Beneath our feet, the planet is alive with movement, forever shaping the world we call home. Now, let's zoom in on the Pacific Northwest, a region known for its breathtaking natural beauty, dense forests, and dramatic coastlines. Beneath this stunning landscape lies a hidden danger, the Cascadia subduction zone, a massive geological fault that shapes the region's destiny. Stretching for nearly 700 miles from Northern California to Vancouver Island, Cascadia is where the small but powerful Juan de Fuca plate dives deep beneath the vast North American plate, creating a dynamic and volatile boundary. Over millions of years, this slow-motion collision has built the iconic Cascade volcanoes, Mount St. Helens, Rainier, and Hood, towering above the forests and cities below, reminders of the region's fiery origins. But today, Cascadia is locked tight. The plates are stuck together, unable to move, and stress is building up beneath the surface like a giant, compressed spring waiting to snap. Geological evidence, found in layers of sand and soil, reveals that this tension doesn't last forever. Every few centuries, it's released in a massive earthquake, reshaping the land and coast. The last great rupture struck in 1700, unleashing a devastating tsunami that traveled thousands of miles across the Pacific, reaching the shores of Japan and leaving a mark in both history and legend. Since that day, the zone has been eerily quiet, but beneath the tranquil forests and misty coastlines, stress is silently accumulating, setting the stage for the next big event. Today, major cities like Seattle, Portland, and Vancouver are built atop this geological powder keg, home to millions who may one day feel the Earth move beneath their feet. That's why scientists are working tirelessly, installing sensors and monitoring every tremor, hoping to better understand when the plates will finally slip again. The next megathrust quake is not a question of if, but when. A certainty that drives urgent research and preparation. Cascadia's story is one of immense natural power, scientific discovery, and the ongoing challenge of living with uncertainty in a restless landscape. Understanding this hidden threat is crucial for the millions who call the Pacific Northwest home, and for the generations yet to come. For decades, geologists believed subduction zones acted as single solid sheets, massive slabs of rock sliding smoothly beneath continents. This simple model shaped our understanding of how continents grow, mountains rise, and earthquakes strike, but new research reveals a far more intricate reality. The Cascadia subduction zone isn't dying in one sudden catastrophic event. Instead, it's unraveling slowly, almost imperceptibly, as the land fractures and erodes, piece by piece, over thousands of years. Picture the Juan de Fuca plate as a train, not leaping off the tracks all at once, but derailing gradually, one car at a time, each section coming loose before the next, in a slow-motion disaster that takes millennia to unfold. At Cascadia's northern edge, the plate is fragmenting dramatically. A massive chunk has already dropped 5 kilometers into the depths, leaving a scar on the ocean floor and reshaping the coastline above. This process, known as piecewise termination, means the subduction zone is breaking up in segments rather than failing as a single unit. Each segment tells a different story of stress, fracture, and slow-motion collapse. The evidence is clearest where the Explorer plate meets the Juan de Fuca. Here, a massive block is nearly detached, hanging on by a geological thread, hinting at the next chapter in this tectonic drama. This discovery is revolutionizing how we understand the evolution and eventual death of subduction zones. It challenges old assumptions and opens new questions about Earth's restless surface. Tectonic plates aren't unbreakable. Over millions of years, they can fracture, splinter, and disintegrate, leaving behind a patchwork of broken rock and new boundaries. For the first time, we're witnessing the slow demise of a subduction zone as it happens, an extraordinary opportunity to observe Earth's deep time processes in action. This insight reshapes our view of Earth's most powerful geological features, reminding us that even the mightiest forces are subject to change and decay. The end of a subduction zone is a drawn-out, complex process, one that unfolds over eons, not in a single dramatic moment. Thanks to modern science, we now have a front-row seat to this transformation, watching as the planet's surface is slowly, inexorably, rewritten. How did scientists uncover this hidden drama beneath the ocean floor? They used seismic imaging, essentially a geological ultrasound. A research ship towed a 15-kilometer streamer packed with hydrophones, listening for echoes from sound waves sent into the Earth. As sound waves bounced off different rock layers and faults, the returning echoes painted a 3D map of the deep crust. The results were stunning. Instead of a smooth plate, they saw massive tears and fractures. A huge block of the Juan de Fuca plate had dropped, nearly breaking away. This seismic X-ray provided undeniable evidence of the plate's slow disintegration. Through sound, scientists revealed secrets the Earth had hidden for millions of years. It's a breakthrough in understanding our planet's inner workings. What happens when a tectonic plate fragments? When the plate is whole, stress builds evenly, setting the stage for a massive earthquake. But when a piece breaks off, it creates a gap. The plates are no longer locked in that segment. The result? Seismic quiet zones where stress can't build or release. Earthquake records show a patchwork of active and silent sections along Cascadia. The quiet zones likely mark where the plate has already broken away. This changes the earthquake risk. Instead of one giant rupture, future quakes may be more segmented. Some sections could still unleash powerful earthquakes, but over shorter fault lines. Understanding fragmentation is crucial for accurate hazard models. It helps predict where the next big quake might strike. The future of Cascadia's earthquakes is now a story of segments, not a single catastrophic event. This discovery is a Rosetta Stone for Earth's history. All over the world, geologists find microplates, fragments of ancient subduction zones. Until now, how these fragments formed was a mystery. Watching Cascadia's slow breakup gives us a living example of this process. Scientists can now compare today's fractures to ancient microplates, testing theories about plate tectonics. This helps us understand the life cycle of subduction zones, from birth to death by fragmentation. Subduction and plate recycling have shaped continents and climate for billions of years. By witnessing Cascadia's end, we unlock secrets of Earth's deep past. Today's geology is the key to understanding our planet's epic story. Hearing that Cascadia is dying might sound reassuring, but the risk remains. The plate's fragmentation is unfolding over millions of years. For us, the danger is unchanged. Most of Cascadia is still locked, still building up stress for a future megathrust earthquake. The big one is still a certainty, not a myth. This new research refines our understanding but doesn't erase the threat. It helps scientists target hazard maps and improve preparedness. Better models mean better building codes, evacuation plans, and public awareness. Science gives us tools to coexist with Earth's power, but not to escape it. The Pacific Northwest remains a place of immense geological energy. Our best defense is knowledge and readiness for a restless planet.